Hello and welcome to this class on Java inheritance. My name is John Maxwell. I apologize, I have a little bit of a sore throat. Hope it doesn't get worse, so you're going to get a scratchy voice today. Well, to give you a preview about inheritance, it's one of the great features of Java. It does inheritance very well, and we can explain a bunch about why it's particularly useful in designing software. So we're taking, as one student pointed out, a systematic approach. So you can see multiple applications of this. And we'll start off by introducing the concept of a vehicle class. You can see it here on line 2 in the left. Okay, and I'm just going to close the package Explorer, but you can see already I'm working in Eclipse and brought in this lesson that I developed with my regular class. So what's a vehicle? It could be a lot of things, but the private instance variables or the fields or the data behind a vehicle I've limited to make, model, year, and power system. And I put a little comment: gas, diesel, electric, human, animal, or other. They all can be vehicles. And we're talking about really the things that go over the land. Okay, so that is a vehicle, and it's really quite ordinary. It builds off of our knowledge of classes. It has a default constructor, leaves the variables in the initial state, and I'm referring to the instance variables up above in lines 4 through 7. And then we have a more useful constructor on line 12 that takes the make, the model, the year, and the power, and sets those parameters, make, model, and year, and sets the values into the instance variables. And because they're the same name, okay, we have to differentiate between the model up on line 4 and the model in the parameter list. And we do that by saying this dot model up on line 4 equals the value in model, which is the parameter. A bit more explanation about this. This is sort of self-reflexive when you say me, myself. Okay, that's a self-reflexive type of statement in English. This refers to the object itself, and it's a little bit tricky because the object is created in another context. Okay, it's created in another file. You create that object by calling the new operator and calling the constructor, and when that happens it places an object in memory, and so it's a reference in memory to itself, and that's what this is about. So it's really quite ordinary. We have toString on line 18, set make, set model. toString is an accessor, provides information about the object. Set make, model, and year allow the fields or instance variables to be changed from outside the class. Remember, the purpose of a class and the modifiers and accessors is to regulate the flow of information to and from that class. And so we have get make, get model, get year, and a compare to, which compares the year of the car or vehicle and returns either 0, -1, or 1. And also a get power and set power, which are similar type of accessor and mutator methods. So it's really quite ordinary based on what we have experienced. Okay, it's just a class that we learned about 2 modules ago. But shifting our attention to line 2 over here in a car class, we notice public car class car extends vehicle. So let me say this carefully: a car is a vehicle, and that is a statement that they use in this course and on the AP websites is a relationship. So, you know, my name is Maxwell, and I am Maxwell. Okay, but I'm also my own person. So while I have certain things from my family, the parent class vehicle, I extend it to be my own person, right? And car extends vehicle in the same way. And while a car has all these instance variables, model, make, year, power, it also contains something like liters. And, brief description of liters, it's how much gas goes into the cylinder. So when you see a larger liter, it's burning more gas, okay? So a lot of cars are described in liters. And so we add that information and create a constructor. But notice on line 7, very important over here, let me click it again, it has super, make, model, year, power. And so what does super mean? It's the superclass vehicle. And what we're doing is on line 7 calling the constructor on line 10 in the vehicle, 12 on the vehicle class. So one thing that you need to know is the call to the super constructor needs to be the first line in the child class, in this case car, constructor method body. Okay, so you can't reverse it. This dot liters equal liters and then super. No, it's got to go first. All right. And so basically what we're doing is calling the superclass constructor on line 10 from line 7. And the make, model, and power are saved at that level, the vehicle class. And that's where that information is stored. And it seems a little bit different at this point, okay? But we'll explain a little bit more in a couple of minutes. Completing out the car class, you'll see the toString. And the toString overrides the line 18 toString, or overwrites, okay? And so we've talked about method overloading, but this is method overwriting, or overwriting is what it's called, right? And it's when the child class has a duplicate method that the parent class, in this case vehicle, has. So it's called overwriting, and it changes the behavior of the way the toString operates for a car. And we return super.toString, which really just calls the method on line 18. Super refers to the parent class method. Okay, so super dot refers to anything in the parent class plus liters. So we've changed the toString method in car class to include the information from the parent class, but also liters. Okay, so it provides a fuller information about the car. And then we add a get liters, which is returning the liters, the private instance variable from the car class. Okay. Now, the good thing is that we can extend the vehicle class in many other ways. So we have motorcycle, that's also a vehicle, and it extends the vehicle. So I want to say on line 2, you can see that, okay, that introduce the concept that Java has a single inheritance model, okay, which means that it can't extend more than one class. All right, so it's single inheritance. Other languages have multiple inheritance. You can have two parents, but in Java you only have one, the parent class, in this case vehicle. Now, motorcycles are rated by cubic capacity, or CC. Okay, you ever wonder what those were about? And again, there's a constructor on line 8 that calls the parent class constructors. Got to be the first line in the child class constructor, and then it goes over and sets those variables into the parent class and sets the CC, or cubic capacity. And likewise, it overwrites the string toString method so that it calls the parent class toString and then adds cc, the information stored in the instance variable, to the end of the string that's returned. So let's look at vehicle tester and say this is where it all comes into play. We have a car, a motorcycle, and notice this, we created a car C here and we call a get model. But I want to point out that there's no get model in the car class. It's in the vehicle class. Okay? So an instance of the child class can use every public method in the parent class. So there's no duplication. You don't have to, redo everything when you create a car. You just use the information in the parent class, and the compiler and the Java system knows where to look. Okay, so that's pretty interesting, and I'm just going to run it, or I have run it, and it outputs a chord because that's the model of the car that I created in line 5. So understand the first benefit of using a parent and child class relationship inheritance is that you don't have to duplicate methods in the child class. You can simply use the parent class methods. You have full access to anything in the parent class. Now I want to talk about this parent class access. Okay, and you use an example. You can go into your family home, open the refrigerator, and take out a glass of milk, or pour yourself a glass of milk, or any juice that's in there. That's open to you. Probably, you can do that. All right, and so you can access anything that's publicly available in your house. But you can't log on to your parents' bank account. I very much doubt it. Okay, and that's because that's private. And so a child class can access anything that's public in its parent class. And that's how we can access in line 7 the get model. And we understand that car is a vehicle. Remember I said it's a vehicle. And watch what I do here. Vehicle. Okay. Wow, it doesn't change anything because it knows that car is a vehicle. I put a new car here into a vehicle shell. Let's pause. Introduce a word. Polymorphism. That's just what on there. Okay. The car, C, is both a car and a vehicle. Is a. And so you can be your parent or be put in a parent shell. And that's really useful because take a look. I can create an array list of vehicles and add both the car and the motorcycle that I create in line 6. And when I call a method by motorcycle, it knows where to look, mostly. Okay, so perhaps we'll talk about that in a second. So let's summarize, okay, a bit. There's great utility in extending a parent class. You can only extend one class. You can access methods in the parent class from the child class by using the keyword super. You can also call the constructor, must be in the first line of the child class constructor, simply using the word constructor. Using the word super, I'm sorry. So here we have like the idea that a car can go into a vehicle object, okay? And a car can call the get model method of its parent because it's public. But we have greater range by being able to create an array list of vehicles and put every type of object, motorcycle, car, truck, whatever we extend from the vehicle class into that array list. So you can have like a real neat parking lot array list. And so that's pretty useful. You know, the other object is, like, I always use this example. You know, your Sony TV has like an operating system and it has methods, change channel, connect to internet. It has a number of features inside the Sony TV, and many of them are common to all the models. But you have one model, okay, that's a little bit different. So you make it a child class, it can access all the functionality of the generic Sony TV, but yet override or add new behaviors that are specific to that model. So it creates a lot of versatility in terms of design. Okay, you can simply create a bank account, and you can have subclasses, checking and savings, but they all may use the deposit and withdrawal methods in a similar way. It's just that the savings has an interest, rate, and the checking may not. Okay, the checking may have a fee. You can override various aspects with the child class, and if you're careful, you can design a complete software system using it. Okay, and let me tell you, if I haven't said before, the art of programming is the passing of messages to and from different parts of the software system, and that is accomplished, okay, through the use of methods. Okay, in come the parameters, out go the return types. That is one way that it's accomplished. We'll talk more in the future. Now, I want to look at this. C.getLeaders instantly becomes an error. Okay, because I cast it as a vehicle. Here it is, new car inside a vehicle shell. What's wrong? Car has a get leaders right here. Why is it erroring out? Well, it's because when it's trying to compile, it's looking at C, the vehicles, and not finding a get leaders method there. Okay? So sometimes casting it as its parent up here can produce problems, but I'll just show you that, like, you can simply cast it as a car, okay, and because the priority of casting is lower than the call to the method, we need to make sure it casts first before calling the method with parentheses, do this first, cast it as a car, and the error goes away. I have to tell it that it's a car because it can't find the get leaders method at compile time inside the vehicle class. Okay, well, I didn't have to do that with get model because it found the get model method in the parent class vehicle. Okay, so it knew which one to run. That is another topic called dynamic binding, but we'll just run this and say, yes, we printed out the model. Yes, we've printed out the Accord, a 2.0. We've called the toString method on the car, and it calls the appropriate toString method. Look, right here, toString. Adds the leaders. So why did it not have a problem that we had with get leaders? See, here, systemout.println automatically calls the toString methods. That's why you want to put one in every class that you design, because you want to represent, okay, the way the object is going to display. Well, the reason why there wasn't a problem with this is it saw a two-string method inside the parent class, the vehicle class. So when if I can compile, well, yeah, it's this one over here in the vehicle class. But at runtime, it shows the right two-string because deep down, the system knew that C wasn't a vehicle, and we shouldn't run the vehicle class two-string method. It knew the contents of that C was created using a car. And that's what we mean by dynamic binding. When it runs, it gets the right method. But when it's trying to compile and it can't find the method, then we have to cast. And that's static binding. So 11 is an example of the error that we got of static binding, and 12 is an example of dynamic binding. Hey, I'm running this and I'm going to get the two-string method that's in the car class. And then we have a compare to, which is compare C to vehicle B. And we didn't talk too much about compare, but it just compares based on year. And they're different years, 2014 to 2023, okay? They're not the same year. So C comes before 2023, 2014. So it returns a negative number, and you can see that over here. Remember, compare to returns 0 if they're equal, negative if the calling parameter, in this case C, also known as this, comes before the parameter object, and 1 if vehicle B came before the calling object C. And notice the casting here, okay? Because B, motorcycle, did not have a compare to method, so it said, I can't find one, right? I can't find one there, a compare to. So we cast it as a vehicle so that it would call the appropriate variable. Method, I'm sorry, and it would be of the appropriate variable type. Wow, there's a lot there, and you're just going to get better by experimenting with it. I covered a little bit more in the class. We also went over the labs and how to get them working in a variety of situations. So, and how to install Eclipse, gave some brief information, but reach out if you have any issues with that. I've been getting some emails about, like, I'm stuck here. Just share your code and copy it, and I can look at it and see. And that's what I wanted to say today about inheritance. So, good luck, and reach out if you have any issues.